Hello everyone. Today we'll be going over Chapter 9, otherwise known as hypothesis testing. Here's an outline for this chapter. It covers one topic, which is hypothesis testing, and that topic is broken down into three subgroups. The first is hypothesis testing using z-scores, the second using t-tables, and the third using proportions. We'll see an example of each using problems 4 for z-scores, 1 and 5 for t-tables, and problems 2 and 3 for proportions. Steps to solve any hypothesis question. The steps are usually the same. The first step is always to state your hypothesis. There's two hypotheses you can have, and the first one is called a null hypothesis, and the second is called an alternative hypothesis. The null hypothesis is the standard which the company states, and the alternative hypothesis is this new standard they're trying to prove right or wrong. The meaning of based on the law approach means that the null hypothesis is considered true as long as it's not proven false and the alternative hypothesis is proven true. Step 2 simply means identify the alpha. To find the alpha, you just take 1 minus the confidence level, and the difference is the alpha. Step 3 is determine which method to use, Z, T, or proportions. This is done similar to Chapter 8. It's simply done by following the chart and understanding how big the sample size is and if we have a standard deviation or not. Once that's done, we're going to use one of the three formulas located in Step 4 to find the cutoff points. The cutoff points happen to be the same thing as a confidence level. And then Step 5 is simply to find the critical value. And again, the critical value has three different formulas, each of which is used for the appropriate method. Let us begin problem 1. Problem 1. An engine manufacturer is testing the amount of air pollution in milligrams per cubic meter of exhaust emitted by a new rotary engine. The manufacturer randomly selects 4 rotary engines and subjects them to a pollution test. It is found that these 4 engines emit 71, 74, 73, and 74 milligrams per cubic meter. A. Assuming normality, construct a 95% confidence interval for the mean emission of air pollution by the rotary engine. So before we get started, let's highlight the important information the problem gives us. They give us a confidence level of 95% and 4 values. As you can see, the formula we need is right here, and it requires us to have a standard deviation, which we don't have. We do have all the values of the sample. So the first thing we have to do is find the mean of our sample. So we're going to add up all our values, 71 plus 74 plus 73 plus 74 divided by 4 gives us a mean of 73. Then we need to find the standard deviation, which we will start by 71 minus the mean squared plus 74 minus the mean squared plus 73 minus the mean squared plus 74 minus the mean squared. And we're going to divide the entire thing by 4 minus 1, and that will give us a value of 2. That value represents our variance. So now to actually get the standard deviation, we have to take the square root of 2, which gives us a value of 1.414. Now that we found our standard deviation or simply S, we can plug in our values into the equation. We have our mean, which is 73, plus or minus our t, with our standard deviation 1.414 over the square root of the number of variables in our sample, which is 4. All we're missing is to find our t. Since we know the confidence level is 95%, we could do 1 minus 0.95, which gives us 0.05, and we need to divide it by 2, which gives us 0.025. We would go find that value, and with 3 degrees of freedom on our t-table, which would give us a value of 3.182. I'm just going to rewrite the equation. therefore our t-value was 3.182, and that'll give us a confidence level of 70.75 and 75.25, which we can graph. Which simply means we are 95% sure that the true mean is between 70.75 and 75.25. Let us move on to problem 1b. B. A computing piston engine has a mean air pollution emission of 77 milligrams per cubic meter of exhaust. Would it be reasonable to claim that the mean emission of air pollution for the rotary engine is less than that of the competing piston, using an alpha of 0.05? So now, since this is a hypothesis question, the first step is to identify HO and H1. HO, being the null hypothesis, is the standard. So we could say that our mean is the same as that of the competition. Now H1 is what we're trying to prove, and we're trying to prove that our mean is less than the competition. So our mean would have to be less than 77. 77 being the mean, and we're trying to prove that we're on one side of it, less than, to the left, would mean that it's a one-sided test, therefore we don't have to divide the alpha by 2. So our alpha is 0.05, and our degrees of freedom, which is n minus 1, will be the same as the other problem, the problem right before, equal to 3. We need to find our cutoff point by looking up these two values on a t-table, which would give us a t-value equal to 2.353. Now this value could be positive or negative depending on which side of the table or the distribution we're on. Now we need to find our critical value using this formula, and all we have to do is plug in the values we found in part A. So in part A, our x was 73 minus the mean of this problem, which is 77, divided by our standard deviation, which was 1.414, divided by the square root of our sample size, which is 4. This gives us a value of 5.6577, which means our cutoff point would be here at negative 2.353, and our critical value would be here at negative 5.6577. And since our critical value is below our cutoff point, we can reject HO, stating we have sufficient evidence to support that the mean is below 77 milligrams. Let us move on to problem 2. Before we begin, let's make a small correction. This is not the formula we want to use. Instead, we're simply going to use the z-squared formula, which is x minus mean over the standard deviation divided by the square root of n. Now, let us begin. A student claims that his high school is attended by students of above average intelligence. To test this claim, the standard IQ test is administered to 25 students selected at random. These students produced an average IQ score of 103. If previously published studies have standardized IQ scores at a mean of 100 and a standard deviation of 10, test the student's claim at a 2.5 level of significance. State the p-value. So now let's highlight the important information the problem gives us. It tells 25 students wrote the exam. which would be our n, and they had an average score of 103. However, the population has an average score of 100 with a standard deviation of 10, and they gave us a significance level of 2.5%. So now the first step is to state both hypotheses. HO, which would be the standard, would be that the mean is equivalent to 100, since we'd have to assume that this school is the same as every other one. And then H1 would be our claim that this school is above in terms of intelligence than all the other schools, so our mean would have to be greater than 100. So now, using our alpha, which is 0.025, we would have to find our test point, or our cutoff point, which would be found on a z-score table. And we'd have to look up on the z-score table the z-score equivalent to 97.5%, which is simply 1 minus our alpha. And that would give you a z-score equivalent to 1.96. This represents our cutoff point. Now, using this formula, we would have to go find our critical value, which we would use our new mean of 103 divided by the population mean of 100 divided by 10 over the square root of 25, and that would give us a z value of 1.5. Graphically, that would mean our critical value would be here, and our test point, or our cutoff point, would be 1.96, would be here. Since our critical value is to the left or below our cutoff point, we have to say that we cannot reject HO. We have insufficient evidence to do so. Now, the problem also asks us to find the p-value. The p-value is simply the probability to the right of our critical value. So if our critical value was equal to 1.5, that value is equivalent to, on a z-score table, a probability. If you would go look it up, it would give you a probability of 0.9335, which would be all of this. However, the p-value is to the other side, so we would have to do 1 minus that probability, which would give us a value of 0.0668, and this would be our p-value. Let us move on to problem 3. Problem 3. A software developer is in the process of estimating the average cost for its new mid-sized projects in the coming year. While it's reasonable to assume that the average time taken to complete a project remains the same, for the coming year, the cost in dollars incurred for a project should be calculated differently, and is given by the following formula, where X is the number of days taken to complete the project. A sample of 35 past mid-sized projects is taken. It is found that the mean and standard deviation of the project completion time for this sample are, respectively, 27.2 days and 5.5 days. Furthermore, 15 of these projects used Visual Basic as the main tool for the project. AI. At a 5% significance level, is there any evidence that the proportion of the project using Visual Basic as the main tool is different from 0.25? Justify your answer. So now, before we begin, let's highlight the important information the problem gives us. They give us a formula for the total cost. It tells us the sample size is 35. They go on to say that the sample gave us a mean of 27.2 days and a standard deviation of 5.5 days. They also tell us that 15 of these projects used Visual Basic as the main tool, and they're asking us to find if the proportion is less than or greater than 0.25. So now we can begin. Since this is hypothesis testing, this is a hypothesis question. The first thing is we have to state our HO and our H1. Our HO would be simply that P is in fact equal to 0.25, and H1 would be equal to that P is not equal to 0.25. Now we need to actually find the proportion in our sample. And in our sample, there were 15 out of 35 projects that used Visual Basic, which gave us a proportion of 0.4286. Now, given that value, we would have to find the critical value based on our confidence level, which is here. However, since our significance level, or alpha, is equal to 0.05, but our hypothesis 1, or H1, states that P could be either lower or above 0.25, we have to divide it by 2 to give us 0.025, and then we'd have to go find that value on our z-score table, which would give us a z-score equivalent to 1.96, and this would be our cutoff point. Now we have to go find our critical value using the formula here, and that would simply be our proportion of our sample, 0.4286, minus the one we're testing, which is 0.25, divided by 0.25 times 1 minus 0.25 over n, which was 35, and the square root of the entire thing, which gives us a value of 2.44. And this graphically would represent our cutoff points would be negative 1.96 and positive 1.96. And our critical value happens to be to the right of our higher cutoff point at 2.44, which means we have sufficient evidence to reject HO in favor of H1, and that would meaning that the true proportion of projects using Visual Basic is not equal to 0.25. Problem 3a2. Calculate the p-value of the test statistic. So, from the previous problem, or previous part, we know that our test statistic is equal to 2.44, which would be somewhere here. And our p-value is simply the probability to the right of that value. We're looking for here. So we would have to go find 2.44 on a z-score table, and that would give us a probability of 0.9927. However, that value represents this side, and we're looking for the side to the right. So we have to take 1 minus that value, which gives us 0.0073. However, remember that we divided the alpha by 2, and the point of a p-value is to compare it by the alpha. So if our alpha is going to be 2 times bigger than our cutoff point was, so must be our p-value. So we're going to take our p-value and times it by 2 to give us 0.0146. And this value here is our final p-value. Let us move on to 3b. 3b. At a 5% significance level, is there any evidence that the mean cost for the mid-sized projects will exceed $40,000 in the coming year? Justify your answer. I, or 2I, calculate the p-value of the test statistic. So now the important thing to realize is this question is asking you a question in terms of dollars, while the problem gave you the numbers in terms of days. So we have two options. We can either transfer the dollars to days or the days to dollars. Since it would take only one transfer to get this value, 40,000, to days, that's what we'll do. The problem gave you an equation which stated that total cost was equal to 10,000 plus 1,200x. So now this question is telling us that the total cost is 40,000, and we need to find how many days is that equivalent to. So the first step, we're going to bring over the 10,000, subtract it. That'll give us 30,000 is equal to 1,200x. Divide both sides by 1,200, and that will give us x equal to 25. Now that we have everything in days, we could begin. The first step again is the state HO and H1. HO would be that our mean is simply 25 days. The average cost is 40,000. Now H1, what we're trying to prove is that our average cost is actually above 40,000 or should take longer than 25 days. Now we could move on to finding the Z score. Given a significance level of 5%, and since we're only dealing with above 25,000, it's one-sided, we could simply look up 0.05, which is our alpha, on the Z-score table, which would be equivalent to looking up 95%, and that would give us a Z-score of 1.645. Now we need to find our critical value using this formula, which would be 27.2, which was found before, minus 25 over 5.5 divided by the square root of 35 gives us a value of 2.37. And now we can put that graphically. Our cutoff point would be here. And now our critical value would be here, which would mean that we have sufficient evidence. We have sufficient evidence to reject HO in favor of H1, meaning that the average number of days is greater than 25. Now the last part of this question, which is II, tells us to find the p-value. The p-value again is simply the probability to the right of our critical value. In this case, if you were to look up 2.37 on the Z-score table, it would give you a value of 0.9911. And since we're looking for the value to the right, and this value represents the probability to the left, we would have to do 1 minus 0.991 equals to 0.089. And since we only tested one side, and we didn't divide our alpha by 2, we don't have to multiply this value by 2. And this value would be our final p-value. Problem 4. A book club advertises an introductory offer through which new members are entitled to receive an initial package of books at a nominal price with no obligation to purchase additional books. The club estimates that this promotion will be profitable if new members buy on average at least 2.8 books during the following year. A random sample of 100 records of members attracted by this offer showed a mean purchase in the next year of 2.61 books and a standard deviation of 0.9 books. A. Can you conclude that the promotion was profitable at a 0.05 significance level? Before we begin, let's highlight the important information the problem gives us. It gives us the significance level of 0.05, the standard deviation of our sample, which was 0.9 books, the mean of our sample, which was 2.61 books, and 2.8 books being the minimum requirement to be profitable. And it also gives us a sample size of 100. The sample size is important since, if you remember, if n is greater than or equal to 100, we can use z, and if not, we should use t. In this case, we should use z. However, I will use both, just to leave the option open to those of you who use t anyways. So now, the first thing we want to do is, we want to state HO and H1. Our HO would be that this promotion was in fact profitable, and that the standard deviation, or no, actually the mean, is equal to 2.8. While H1 would be the side stating that the promotion was not profitable, and that the mean was less than 2.8. Now, what we have to do is we have to find our test point, or our cutoff point. So to do that, we have to find the alpha, which our alpha is given to us as 0.05. And since this is a one-sided test, we're testing it only if the mean is below 2.8. We do not have to divide by 2. We have to go find on the z-score table, the z-score equivalent to an alpha of 0.05, which gives us a z-score of 1.645. And in case anyone used the t-table, you'd end up getting a value of 1.66. These values are so close together, and that is why at n greater than or equal to 100, you would definitely use z. And this little difference would make no difference. So from this point on, I will use z. So now that we have our cutoff point, we have to find our critical value, which the formula for is right here. And we'd have to plug in. The sample had a mean of 2.61 minus the population mean, 2.8, over the standard deviation, which was 0.9, over the square root of 100. And that gave us a value of negative 2.11. Since we're dealing with a critical value that is negative, we'll have to use our negative z-score as the cutoff. And since our cutoff is 1.645 and our critical value is to the left of that or below that value, we have to reject HO. We reject HO. We have sufficient evidence to prove H1, that the true mean is below 2.8. Therefore, that would mean that this project is not profitable. Problem 4b. What is the p-value of the above test? Problem 4c. According to your answer in part A, would you be subject to making a type 1 or type 2 error? Explain. Let's begin with B. To find the p-value, you have to find it using one of two methods, either the z-score method or the t-table method. We'll start with the z-score, and then I will do the t-table method as well, just in case. For the z-score, all you have to do was Find your z-score, which was negative 2.11 on your z-score table, and find the probability of it being less than that value, and it gave you a probability equal to 0.0174, which meant that the probability to the left of the z-score of 1.11 is equal to 0.0174. Now, for the t-table method, you'd have to look up the same point, negative 2.11, or positive 2.11, since a t-table doesn't have a negative side. And with the differences with a t-table, it wouldn't give you an exact answer, it would give you a range. And it would give you a value in between 0.01 and 0.025. And in both cases, t-table, this would be your p-value, and with the z-score, this would be your p-value. Now for C, in part A, would you have made a type 1 or type 2 error? The answer is type 1 error, since we rejected HO, and type 1 error means to reject HO when it is in fact true. Let us move on to problem 4D. Problem 4D. If the book club wants to reduce the standard error used in part A by half, how many records should be sampled? So the key question, or the key part of this question, would be to understand that standard error simply means standard deviation. Now, the question's not asking about the standard deviation of the sample, but rather the entire population, which we know that we can assume the standard deviation of the entire population is equivalent to the standard deviation of the sample divided by the square root of the sample size. Therefore, in part A, we had 0.9 divided by the square root of 100, which gave us 0.09. And the question is asking us, how big does n have to be to get this number to be 2 times smaller? So to solve that, we're going to take 0.09 divided by 2, which gives us 0.045, and we're going to replug that number into the formula, leaving n as a variable. So the new formula would be 0.9 over the square root of n equals 0.045, and now we're simply going to solve. First thing, we're going to cross multiply, giving us 0.9 equals 0.045 times the square root of n. We're going to divide both sides by 0.045, 0.045, cancel. That'll give us 20 equals to the square root of n, and then we're going to square both sides, and that'll give us n equals to 400, which means if the book club wants to reduce the standard error by half, it should sample 400 records. Problem 5. In 1991, the average number of days that homes in Canada stayed on the market before being sold was 105. A real estate broker in Montreal believes the average number of days that a house in Montreal stays on the market before being sold is less than 105. 15 houses were sold in Montreal in 1991 were randomly selected, and the average number of days that the houses stayed on the market was 95.53 days, with a standard deviation of 15.39 days. Assume a normal distribution. A. Does the data provide sufficient evidence to conclude that the mean number of days that houses in Montreal stayed on the market before being sold is less than 105. Use an alpha equal to 0.01. Before we begin, let's highlight the important information the problem gives us. Alpha is 0.01. The mean is 105. Someone believes the mean is less than 105. A sample of 15 houses was taken, and that sample had a mean of 95 days, well 95.53 days, and a standard deviation of 15.39 days. Given this information, we can begin. Firstly, since n is equal to 15 and the standard deviation for the population is unknown, we have to use t, or a t-table. And now let's begin by finding our HO and H1. HO, H1. HO would simply be that the mean of the number of times or days a house in Montreal stays in the market is the same as the rest of Canada, equal to 105, while H1 would be that the actual mean is less than 105. Now, given an alpha of 0.01, which we do not have to divide by 2, since H1 is testing only one side, it being less than 105, we need to find our degrees of freedom before finding our t-table. So our degrees of freedom is simply n minus 1, which would be 15 minus 1, and that would give us 14 degrees of freedom. So the t value equivalent to an alpha of 0.01 and 14 degrees of freedom would be equal to 2.624. And now we must find our critical value to compare it to using this formula. Our x, or the x of our sample, is 95.53 minus the mean of the population, 105, divided by the mean of our sample, or actually the standard deviation of our sample, 15.39, over the square root of our sample size, which is 15, and that will give us a t value equivalent to negative 2.28, negative 2.38. And since our critical value is negative, our test point must also be negative. We're going to put both of them on the distribution. Our cutoff point is negative 2.624, with our critical value being negative 2.38. And since our critical value is above our test point, and we're dealing with a left side tail, we do not reject HO. We do not have sufficient evidence to reject HO. Let us move on to problem 5b. Problem 5b. Will the conclusion you made in part A change if the significance level is changed to 0.05? And C, what is the p-value of the test? So for part B, all you have to do is change your cutoff point. We found the cutoff point for 0.01 and 14 degrees of freedom. Now for B, we have to find the t-value equivalent to an alpha of 0.05 and 14 degrees of freedom, which would give us a value of negative 1.761. We could draw that out. New cutoff point would be somewhere here. However, our critical value does not change, and it would still be negative 2.38, which would now be to the left of our cutoff point, which would mean yes, if we change the significance level the results in A will no longer be valid, as we would now reject HO in favor of H1. And for C, what is the p-value of the test? All we simply have to do is go on a t-table and look up the value negative 2.38, but since a t-table doesn't have a negative side, we just ignore the negative and look up 2.38, which would fall in the middle of 0.01 and 0.025. So the p-value for the test would be above 0.01 but below 0.025, and this would be our p-value. Now, for those of you who are still a little unsure on how to find the p-value for a t-table, here we have a graph for a t-table. So what you have to do is, we're dealing with 14 degrees of freedom, which will put us into this row. You would simply go find our critical value, which was 2.38, in this row, which as you can see is not there, but it would be in between these two values, somewhere here, which would mean that our p-value would also be in between these two values. And that's your p-value. That's it for this video. Thank you very much, and I hope to see you guys next time.